Today we are going to discuss about virtual manufacturing. This session today is going to be about virtual manufacturing. What is virtual manufacturing? What are the different aspects to it? Different types of software that enable virtual manufacturing, etc. So I'm just going to take you through an overview of the table of contents now that we will be discussing in the next coming half an hour, 45 minutes. So virtual prototyping. What is computer aided design? So I'm assuming that most of my audience today are going to be people from the mechanical background, the mechanical engineering background. If that is the case, I think it will be a little bit more smoother to understand. So we're going to talk about computer aided design. We're going to talk about 3D experience. So you'd be wondering what is this three new term that we are hearing, 3D experience. It is a new suite of products or a platform. Like what do you mean by a platform? It could be like a single piece of a single installed software on which you can have multiple modules plugged onto it, where different technologies can be enabled. So it's a platform enabled by a company called Dassault Systems. So they are the company that builds a lot of. It's a conglomerate. They produce a lot of softwares and hardware as well. From aviation, they are into aviation industry, automotive industry, etc. So this is so we are going to discuss about 3D experience. We'll have a brief walkthrough on 3D experience. We'll show you about how a virtual design assembly is created, and just going to give you some overview about automotive manufacturing overview. So because I come from the automotive world, any kind of to understand any kind of virtual manufacturing, it is mandatory that you understand manufacturing technology and the basics of it, and some flow of the things that happen in a car assembly plant, for example. This is mandatory to understand. So we will go through that. We will go through bill of materials and bill of processes, and then we will talk about a PPR context, which is the product process resource context. Now PPR context is something that is available within 3D experience. So we'll be talking about that, and then we will be talking about creating the MBOM and EBOM. So what is an MBOM and EBOM? So again, from the bill of materials, we have an extension called E standing for engineering bill of materials and M standing for manufacturing bill of materials. So we will talk about EBOM, and we will talk about how we can create MBOM from the EBOM. What is the difference between that? And then we will talk about process planning. Process planning is an activity of planning for the operations that happen, the processes that has to happen to manufacture an entire product. So we will discuss about process planning, and this is all going to be very brief and very to just give you an introduction into the whole world of virtual manufacturing. And once all of this is somewhat discussed, I would like to give you a brief overview about what are the job perspectives and what are the opportunities that the market has to offer in this domain of virtual manufacturing to the people who are interested in this domain, right? So moving on. Again, we're going to brief you on the learning objectives. So once the session is once you attend this session, you would be able to understand what are the basics of virtual manufacturing. Virtual manufacturing is the concept, and we are going to introduce you the software called as Delmia 3D experience. So Delmia is a suite of product, again based on 3D experience. And what is Delmia? Delmia is a acronym. It was earlier a separate company which was acquired by Dassault and integrated. What is Delmia? D stands for digitally and enabling a lean manufacturing interface application. So it's an acronym, and it is a suite of products. It's a name of a different products and different apps that come inside 3D experience, and they're clubbed together as Delmia. And then we have then we will be learning about virtual design assembly, and what happened, how is digital prototype or how digital CAD data of the whole product, how do we arrive at that? We will be discussing about that, how we will be generating bill of materials and bill of processes. Again, PPR, product process and resource. So obviously you're going to manufacture a product, so you will have your digital product, you will have digital plan of process and digital resources. Resources could be any type of, we'll discuss in detail about resources, what are the different type of resources, etc., that are required to do the actual manufacturing activity. So we will be learning about all of that, and at the end we will definitely learn about process planning, which is the core objective of having a Delmia. That is, how would you manufacture? So that question is going to be addressed by process planning activities. So these are the things that you are going to get a brief introduction on, and you will be exposed to these things gradually in the coming few minutes. So we'll move towards virtual manufacturing. So what is virtual manufacturing? In simple terms, we can define virtual manufacturing as the use of computer systems to model, simulate, and optimize operations in a factory or plant. I'm going to repeat that. It is the use of computer systems to model, simulate, and optimize the operations in a factory or plant. So you'll be able to create virtual models. It could be CAD, and then you will be able to simulate it. Simulate it means to move it, or to different kind of simulations are there. You have your assembly path simulation, you have clash and clearance checks, and you have you could have your stress and strain simulation. You could have heat analysis simulations. So different kind of simulations, and then based on those simulation, it allows when you optimize your model or optimize your processes that happen in a processes. By process I mean operations in a factory or a plant. This entire process is called as virtual manufacturing. So I hope you get some clear idea about that. And then we go into different domains inside virtual manufacturing. So there is something called as virtual prototyping. Prototype, what does the word prototype mean? It is like a initial level of, in your CAD or in your 3D design, how you have a virtual design of your actual product. So the actual product exists in the physical world, which we can feel and touch and see, and the virtual proto exists only in your computer system. It's a CAD design which you could design it before you actually spend even a penny on manufacturing it. So that is called as virtual prototyping. It involves hugely painstaking process of CAD, but yet very cheap than compared to doing an actual prototype. So CAD is computer aided design. I hope people from mechanical background, they'll be exposed to this domain CAD in their colleges. Further, there's another domain called virtual machining. So this is called as CAM, computer aided machining. What it enables is before you actually do a machining activity, maybe on a CNC lathe or on any of those complex new modern manufacturing technologies available, you would simulate those that machining possibility, and you would see that, okay, at what step of my machining, what is my product, or do we have any kind of risk if we take this kind of a machining pathway? Do we face like a case of fatigue happening, or some kind of a risk of of my product having a failure chances during the machining process? So these kind of things can be simulated in virtual manufacturing softwares, and those are also available within the Delmia platform that we are going to discuss. That is called as virtual machining. Moving on, we have something called virtual assembly, or you can say assembly simulation softwares. So what do you say? What do you do with virtual assembly is what would happen in an automotive assembly plant, or like say any assembly plant for that matter, even a toy assembly plant. So you have how do you get complex products? You get complex products when you assemble simple parts. You assemble small parts along according to their degrees of freedom, and then you create complex moving products. So that's how you have the assembly process. So it is very important that the assembly process is streamlined, it is planned, the timings are planned, and the movement of the ergonomics of the person who is placing these who is doing the assembly is well planned. So there is a lot of simulations that need to happen during virtual assembly. So this is what is virtual assembly. Moving on, in an assembly plant, in a actual factory of a OEM, like of a very big factory. So how do you plan the operations? Like you have your systems which enable you to know what is the demand of the product right now in the market, like how many cars have to be produced today, and how many shifts we have to run. For that, what are the raw materials that we require to order? What is the inventory that we need to maintain? So there are these questions that need to be addressed, and to plan and simulate all of those things, and to maintain a track of the whole to maintain a twin or like a digital twin or like the actual the whole plant, to maintain it digitally, you need these virtual operations control softwares, and they are also called MES and ERP softwares. ERP is enterprise resource planning and manufacturing execution system software. Again, there are a lot of softwares that are available to do these activities for manufacturing plants. But here in this, we are going to discuss about Dassault Systems 3D experience for this. There are again virtual testing and virtual validation, and there is a lot of new new methodologies and new aspects to virtual manufacturing that are getting added on to it further. So when I talk about virtual testing, I'm sure you guys have seen about the global NCAP ratings of the cars, and they're doing crash test of the car, etc. So all these automotive companies, they do digital crash tests before even they go and attempt the actual crash test. So they do something called as the virtual test before they go for the actual test. So there are so many different aspects to virtual manufacturing. So what I'm mentioning is the most prominent of those, but there are new niches being discovered and new aspects being added into virtual manufacturing as we speak. Okay. Moving forward, we will first discuss virtual prototyping, or CAD. CAD is computer aided design. So again, CAD, what is CAD? CAD is it's simple. It's like any product that you try to design using a computerized software in 3D or in 2D. So historically, it started in 2D sheets like the one you see on the screen right now. The designers used to draw first using pen and paper and pencil initially, and later on, as the time to market needed to be reduced, so that the design process can be the speed can be increased of the design process. Computerized design has started to happen, and then for initially there was 2D design. There were softwares called like AutoCAD for doing 2D design. From there, the Dassault Systems has built a tool called CATIA to do a design tool, so we can design the car digitally in 3D using CATIA. So this is the how do they design an automotive? They do all the design each and every part in CAD software, and then they start assembling them using by defining constraints. Constraints, if you are mechanical engineering students, you would know the constraints is the process of defining the degree of freedom of any two objects, any two or any different parts together. So once the degrees of freedoms and the fasteners are made at the right points, you get a complex assemblies, and that's how you build up the whole car. In the car design also, there are different aspects. Like for example, you would wonder how do they manufacture a car? So there are different design teams. There's a team called styling design who's in charge, who would be in charge of the look and feel of things. So they would be design experts. They would be artistic in their design process, and they will come up with different styling designs. There is a different defined team called architecture. What do? They define the sizes, the maximum and minimum tolerances that have to be followed for each and every part, starting from say wheel to steering or seats or anything. Each and every part, the architecture team, they define what are the maximum and minimum possible limits, and then there are these actual designers who take that architecture and try to build up the design to match as much as possible to the styling that they have received. This is the whole process that a usual designer in India, in a designer in any automotive company would be going through. So there are different teams. There are styling teams, there are architecture teams, and different dedicated design engineering teams for all the different automotive departments in departments in an automotive company. Like say you have body in white, or you have trims, or you have chassis components, or you have interiors, or you have powertrain. So many different departments are there in an automotive company. I'm just going to speak about automotive because I come from that domain, but in any mechanical design field, it is going to be more or less the same. Next up, what is bill of materials? Bill of materials is what you see on the drawing sheet as well. So this is the most primitive way of defining a bill of material. But bill of material is nothing but a list of all the parts, the quantity, and the name, the part number of that part. Okay, so you have different type of bill of materials, but at this stage, you will have what is called as the engineering bill of materials, or the EBOM. So this is just a list of parts that need to go into the product. So and with the quantity, with the weight, and with the material defined. So that is what is called as the engineering bill of materials. So all of this, the entire process of developing the CAD design and generating the bill of materials and preparing the design to be ready to be manufactured, or to pass it on to plan it for to manufacture. This entire process is called as prototyping, or product prototyping, or creating the digital lot. These are terminologies that you will hear in the automotive industry. So we are now going to talk about 3D experience as a tool. So as I said, 3D experience is a new is a very latest technology, latest platform that is offered by Dassault Systems to do all of this, to do virtual design, virtual manufacturing, virtual planning, etc. I'm just going to give you an overview. So this is what you see now on the screen is the actual screen of the 3D experience platform provided by Dassault Systems software. So this is the logo of Dassault Systems. You have what is called as the compass here. So in the compass, you have different sectors. You see 3D, you have simulations, you have a play button, and so on. So on the right side, you have your credentials and so many different other options to handle the data, to import, export, etc. And you have a search bar here, so where you can search the data. So 3D Experience is a cloud-based software now. Basically, the entire server is on the cloud now. Also, the data, all the CAD data that you design, everything is available only on the server. So previously, some 4 or 5 years back, all the data that you create was in terms of physical files, like you would have for your Word or PPT. So right now we don't have any physical file. Everything is on the cloud, on the internet. So you search for the data, you open the data, you work on the data, save the data within the server directly on the cloud. So that is the advantage of being in the most modern technology. So now I'm going to just play this video and show you how we are going to how the design actually happens. This is just going to be an overview of the 3D experience platform. So right now what you see is the list of roles. So when you click the compass, you get what is called as the roles. So you would be able to see what are the different type of roles available to you. So in the beginning, the moment you click the compass, you get the list of roles, and you can type in the particular role that you're looking for. So these roles are assigned to the engineer. Like for example, there is something called assembly robot programmer, or fabrication robot programmer, or it could be product manager, or report producer. So these are kind of roles that different engineers take up in an automotive company. So once the role is assigned, different roles are assigned, and you choose whichever role you would want to perform. So this is available in a collection called My Roles. And once you select the required role, whichever role you're looking for, you get what is called as the app. So say if you select plant layout designer as your role, you get these are the different apps that are available within plant layout designer. So you can select the app that you're looking for and start using that app to perform that action. So you get a lot of different apps within this. So right now, this is called the search bar. And from here, you will be able to search your required data. So whatever is the data, you would search it and you will get a list of your search results. And from here, you will be able to open and work on that search data. So whenever you search the data, you also get this thing called 6W tags, or like this enables you to help to filter out your search results. This can help you to search on like what kind of data you are looking for. Are you looking for a CAD data, or a document, or engineering specification document, or something, or who has designed this, which are the people who are responsible for that data, when was that data placed on the server, and so on. So you will be able to filter out the data and open it. So this is just an introduction to the platform itself. So we're going to go to the next slide called virtual design assembly. Now we will see how CAD design actually happens. So for doing the CAD design, first of all, like any CAD design, I'm assuming you already are a little bit familiar with CAD design from mechanical background people. So for doing any CAD design, you would have the parts already created. For doing that, you go with the same old structure that you'll go to a 2D layout, you'll create a circle, extrude that circle to create a cylinder, and so on. So once you have the cylinder, you can make it like a wheel and do your design. You have those standard options like extrude, or create a pocket, or create a hole, or chamfer the edges, or fillet the edges, etc., or like smoothen the edges, and so on. So you have a lot of different steps, and then you end up with different parts, like say wheel, or like axle, or different parts that you will be able to create. And then you bring in those parts together to form your assemblies. So once you have imported these different parts in an assembly, you get what is called as the specification tree. This thing is called as a specification tree, where you have like a complex entire assembly of the whole car. You have an assembly of the wheels, you have an assembly of the windows, you have an assembly of the motor, you have the assembly of the equipment, of the structure, of the chassis, of the cables required for the doors, and so on. So sub-assembly, different sub-assemblies are created and then assembled together to arrive at the whole car design. So this is how a normal, in any CAD design, not only 3D Experience CATIA, in any car design or in any design software, CAD design software, this will be the flow. So you go to what is called the assembly design app. Now you are in the assembly design app. What are different features available? Like you have these features called manipulate. This will allow you to move different parts in different directions, and maybe enable you to assemble stuff and so on, or like to do some studies. Like you could take sections and measure different parts and know their dimensions and so on. So the different kind of activities that you would do to enable your design is to really do your design activities is done in this workbench called assembly design. So this is just an introduction into the world of CAD and to show you what happens in the CAD world and how 3D Experience platform can enable you. Again, to just give you a further explanation, what you see on the bottom are called sections. So standard, assemblage, product modification, view, AR, VR, tools, touch, etc. These are different sections. So in this section itself, you would see that there are a lot of new technologies like AR, VR also is now available as a section, so that you could enable get the license for that and literally see this car in your augmented reality tools if you have such and such a hardware for that. And you have different assembly constraints that you can define. So saying that, okay, the center of this wheel should align with the axle and so on. Now, this is how a CAD design is done. So this is just a dummy data of a toy that I'm just taking up as an example right now for the since we don't have an actual product data right now to share, but we can work with this to understand the concept. And this is how the engineering bill of materials is built up. So if that is the world of CAD, now we are going into virtual manufacturing and assembly. So what is Delmia? Delmia is a process planning tool. It enables you to decide how that CAD design that you have till now, how are you going to manufacture it in an assembly plant? That is planned using Delmia. So how do they do? So first, next thing what we need to know is how do they manufacture an automotive product, or how are they going to manufacture a car? So we will go into that in the next slide, and I'm going to explain to you in a very by showing an infographic. Further, what is body in white manufacturing process planning? So in any automotive company, there are two different defined manufacturing sectors. One is called body in white. So what is body in white? Body in white is the outer shell of the car. The outer steel body of the car is called the body in white. So how are they going to manufacture that? And what is the difference between body in white manufacturing and other manufacturing, other assembly parts like the trims and chassis and the final line? What is the difference between these two lines that we are, and how is it going to impact the process planning? This is something that we'll discuss. And then there is also a manufacturing planning that needs to be done for the powertrain components. What is powertrain? Powertrain is it starts from your engine, you have your gearbox and your exhaust systems. So all of this goes into powertrain planning, powertrain manufacturing. Also nowadays, even the electric vehicle, battery pack, motors, everything goes under the powertrain. And then the same product has been used by aerospace and shipbuilding manufacturing process planning also.